Lesson 4, binary numbers. In this lesson, you're going to learn how bits are used to create a functioning number system. You'll understand the relationship between the powers of 2 and the number of bits needed to express a number of a certain magnitude. You'll be able to determine for a given number of bits both the number of possible values, numbers, that can be represented, and also the range of those numbers. Now, as a prompt, yesterday you created your own, yesterday or last class, how we go with this, yesterday you created your own number system using circles and squares. What can we communicate using only 2 symbols? Is there a limit? Well, we can communicate anything we want using 2 symbols. It's just how much space do we have? Remember, we looked at with just 2 symbols, we can have yes, no. If we have 2 symbols and then 2 more symbols, we can have 4 different things, and so on. So we looked at how we could just keep making that more, if you will. So the limit, there is a limit, and it's space allowed. Otherwise, we can just keep creating bigger and bigger things so we can communicate anything we want. Now, activity, binary numbers. You and your partner should each have a pen or pencil, or at least you should have a pencil. Some of these things in the classroom we will do with a partner. You may be doing this individually at home if you're doing it all by yourself. If we're in a classroom situation that's online, then maybe there's going to be a way that I can do something with you or with a partner. Okay, first off, let's look at 1 place value, 2 possible patterns. That means that I can either have a circle or a square. 2 possible patterns, or 1 place value says I have 1 spot. So I can either have a circle or I can have a square. So I only have 2 possible answers. On the other hand, when I have 2 place values, I'll give myself 1 and 2, and then I'm going to give myself a little bit of space here, like this. Okay, now all of a sudden I have a lot more options. Let's see what options I have. I'm going to make myself an O. Didn't want another one of those. I wanted a square. Okay, and I'm going to get rid of the big one. Delete. So, while I just fix this up for you so that it's a little bit easier for you to follow along with. Okay, so if I come over here and I have 2 place values, I'm going to wind up with 4 possible patterns. And what do I mean by that? Well, let's see. Okay. If I have 2 places, I can put a circle and a circle, or I can put a circle and a box, or I can put a box and a circle, or a box and a box. Now remember that box, circle, and circle, box are different, okay? Those are different, just like 21 is different from 12. The order matters. So 2 place values, I have 4 possible patterns. 3 place values, I have 8 possible patterns. Notice all circles, a circle and a square in the middle, 2 squares at the right side, a single square on the left, square on both sides, 2 squares in the front, and then 3 squares all the way through. If I list them, 0, 1, 2, 3, 4, 5, 6, 7, you say, oh, there's 7 patterns. No, there's 8. Computer scientists, we love to start counting at 0. Okay, so in computers, everything starts at 0. So the range is 0 to 7. The number of values is 8. Now, instead of 2 shapes, what if we had 10 shapes? Ooh, wow, that'd be a lot of shapes to keep track of. Circle, square, diamond, kite, star. It's okay. 1 place value, 10 one-shape patterns. Here we go. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 through 9, 10 different shapes. Our numbers are nothing more than shapes. They're just shapes. If we have 2 places, we now have 100 different 2-shaped patterns, or 100 values. Notice zeros on the front, and then we just list 0 through 9 shapes. Then we use a 1, and then 0 through 9 shapes, and all the way until we get 99. You learned how to do this. You learned how to put these patterns together when you were little. Now, if I look at this, 0, 9, 9, what comes next? Hopefully, I can't remember if, okay, some of these it'll actually do it and others won't. 100. And I'll make it bigger so it fills up the spot. Okay, we have 100. We roll this one up and these two get replaced by zeros. This was just counting. It's the pattern that we already know. Okay, where is this heading? It's all heading to binary, to the binary number system. Binary is a number system with just 2 shapes. Instead of a red circle, we use the number 0. Instead of a blue square, we have the number 1. Now, making organized lists and counting in binary. 0, we're going to let 0 be all the red circles. So 0 is just 0, 0, 0. 1 is 0, 0, box, 0, 0, 1. 2 is 0, box 0. Put the 1 in the middle. And so on. Okay? The digits have a value. They've got a place value. How do you know that? Well, remember, if we do 56, we know that that is the same thing as 5 times 10 to the first power plus 6 times 10 to the 0 power, because anything to the 0 power is 1. So remember, place value. This is the hundreds place, or this is the tens place. This is the ones place. Binary is similar. Something like this right here just means if I take this number, I have 0 times 2 squared plus 1 times 2 to the first power plus 1 times 2 raised to the 0 power. Well, I don't have any 2 squared, so there's no 4s. 1 times 2 is 2, plus 1 times 2 raised to the 0 is 1, is plus 1, and that is how I got 3. It's just place values. It's just base 2 instead of base 10. Now, we're going to create a Flippy Do. A Flippy Do is a special paper calculator that's going to help you to convert between binary and decimal values. I have set up on Canvas so that you can print out the template or simply use a blank sheet of paper, just creating this grid that I've got here. Or if we are back in school, instead of printing it out, I'll have this printed out for you. So really it's however you want to do it. You need a piece of paper or the printout from me or your computer. If you need to, pause the video here so that you can draw this in or go to Canvas and print out your Flippy Do template. Now, to create your Flippy Do, not hard, okay? You're going to make your Flippy Do. You're going to just print stuff in here. With your template either written out or printed, in this very top row, you're going to write 2 to the 7th, 2 to the 6th, 2 to the 5th, 2 to the 4th, 2 cubed, 2 squared, 2 to the 0, or 2 to the 1st, 2 to the 0. These are your powers of 2. Then you're going to write your decimal equivalents. So 2 to the 0 is 1. 2 to the first is 2. 4, 8, 16, 32, 20, 64, and 128. So fill in the number or decimal equivalents. Now this next spot, this bottom row, you're going to put zeros all the way across. And then down here where we had the dotted lines, you're going to clip it so it makes like fringe. And when you fold it up, okay, you're going to fold it up, you're going to put a 1 on the back side. Because what we're going to do is you're going to have up to 8 bits. And you're going to fold them up or leave them down, depending on whether it's a 1 or 0. And I'm going to show you how to use your Flippy Do. So at this time, if you're watching this, okay, and you haven't done this yet, please pause the video here and create your Flippy Do. Fill it out, cut the bottoms, fill the back sides in, and then we will continue. So pause your video. Now that you're back, we're going to go ahead and we're going to look at how to use your Flippy Do. Each place value represents 1 bit, binary digit. A bit can be a 0 or a 1. Your Flippy Do has 8 bits, which together make 1 whole byte. Now, we're going to try out your Flippy Do. Okay, we're going to try out that Flippy Do. Okay, so did you try this? Let's go ahead and see how you did and see how to use your Flippy Do. So, I've got my pen on purple. I've got the number 7. Okay, and I want to write it. So I look here at my decimal numbers, and I need to make these add up to 7. So I need 4 plus 2 plus 1. Okay, there we go. And that would equal 7. So I need 1, 4, 1, 2, and 1, 1. And the rest of these, I'll simply pad with zeros. And that will give me the value of 7. Okay, so I had to come up here, figure out what numbers added up to 7, and then mark that. Am I correct? And this is supposed to fade out. Boom, there we go. All right, so good. Now pause the video and try doing 20. See if you can do that. Okay, let's go ahead and work it out together. I've got 20. So I'm going to run along here, and 32 is too much. So I know I don't want a 32 or 64 or a 128. But I can do a 16. Now, from 20, if I subtract 16, because I've already taken care of 16, I have 4 left over. Well, 8 is too much. Oh, I need 1, 4, and then I'm done. So I can pad it out with zeros. And here I have 0, 0, 0, 1, 0, 1, 0, 0. Got it. What happens when you go the other direction? Well, here I can come along and say I've got 0, 0, 0, 1, 0, 0, 1, 0. That tells me I have 16. I have 116 plus 1, 2. And that is going to equal 18. Okay. Try doing it with this last one here. Pause the video and try it. Did you try it? What'd you get? Well, let's check it out. These first 3 are going to be zeros, so I don't count those. I leave the zeros. Now I'm going to flip up the ones. So I'm going to have 1, 16, 1, 8, 1, 4, 1, 2, 1, 1. So 16, so I'm going to add 16 plus 8 plus 4 plus 2 plus 7. I personally do it like this. 16 plus 4 is 20. 8 plus 2 is 10. So now I'm 31. Boom, 31. All right, so you're going to have several of these where you're going to go from decimal to binary and then from binary to decimal. And you can use your Flippy Do back and forth. Remember that this is where you've got your ones and zeros. And these are just flipping up or down. You leave the 0 there, or if you need the 1, you flip it up so you get the 1. All right? You should have this Flippy Do activity guide. Okay? It's got problems all along. You can either open it up online and work it out. I've got a link to it in the lesson in Canvas, or you could print it out and do it on the paper itself. It's really your choice. All right. Now, the solutions are also available, by the way, for the lesson. You can check yourself if you're having problems. Please do let me know. The lesson wrap-up. Okay, a decimal number is a base 10 number with 10 possible different digits. 0 through 9 are digits. Values 0 through 9 are numbers. Okay? The same number represented in two different ways. We've got decimal and binary. A binary is a base 2 number with 2 possible digits, 0 and 1. Okay? So 10, we've got 1 10, 0, okay? Got 10s and 1s. This is, oh, this came out weird. I know why it looks strange. This should be 10 to the first power and 10 to the 0 power. I don't know what happened. It must have just shrunk it. But 10 to the 1 is 10, 10 to the 0 is 1. So if we have 2 of these and 3 of these, you get 23. Here, same value. We have 116 and 1 4, that's 20, plus 2 more is 22, plus 1 more is 23. 23 is the same thing as 1 0 1 1 1 in base 2. Same number or value represented in two different ways, base 10 and binary. Now that we've had a chance to practice, and hopefully you've done the Flippy Grid practice, let's find out what you've learned and what we still have questions about. What I want you to write down on a piece of paper is 3 things that you learned today, 2 things that you found interesting, and 1 question that you still have. So pause and just jot this down. If we're in class, I'd be asking you to share this out in a few minutes. You can pause the video while you write these items down. Now, as a wrap-up, a bit, our vocabulary, is a contraction of binary digit, B-I-T, bit. It's the single unit of information in a computer, typically represented as a 0 or a 1, on or off, true or false. Byte is 8 bits. Okay, why a byte? Just because. You can also, if you look at just 4 bits, that is called a nibble. So you've got a byte is 8 bits, a nibble is 4 bits. Now, if you'd like some additional practice, as well as the Flippy Grid practice, there's a binary crossword puzzle available, and there's in Delta Math, I have a Unit 1, Lesson 4, more Flippy Do practice. There's 10 more problems there, 5 going from binary to decimal, and 5 decimal to binary. See you next time.